Hello and welcome to the Coil Center Conference Room, the Center of Innovative Learning. A fun fact about the Coil Conference Room is that its wall is made of glass, so you can't actually use it for any conferences about confidential or sensitive information. You can, however, use it to do an example of the generalized chain rule. And of course, I mean the title of this set of notes is that it's an applied application. You know, the general chain rule doesn't suddenly change just because you attach a word problem to it. Let me copy this down. The amount in hundreds of gallons of toxic material in a lake is A of t equals 0.8 times t to the 1/5 power plus 2, all raised to the 4th, where here t is time, t is going to be the number of months after a nearby factory starts operating. Let's find a prime of 32. So when we're asked for something like this, we just have to find the derivative first and we plug the number in afterwards. So we're only asked for a prime of 32, but there are no shortcuts because of that. We need to find the derivative a prime of t, and then we can plug 32 in there. So this is the general or the generalized power rule because we've got a function raised to a power. And what this rule says is you use the power rule as you normally would. You take this 4 down, you reduce it by 1, it becomes 3. We get 4 times this quantity, 0.8 t to the 1/5 plus 2 raised to the power of 3. But then we multiply by the derivative of the inside function, of the thing that we're raising to a power. I mean, the general power rule, just as a reminder, to take the derivative of a function raised to a power, the power comes down, the power gets reduced by 1, and then we multiply by the derivative of the function. So that's just what we're doing here. The derivative of this Well, the 0.8 is a constant. It stays put. The 1/5, we have t to the 1/5. Now we're just using the regular power rule. The 1/5 comes down. We get -4/5. And then the derivative of a constant is 0. So plus 0. And we could and arguably should do at least a little simplification here. Let's see, 0.8 times 1/5 is 0.16. I also took this term and you can, multiplication commutes, order doesn't matter. I moved it around a little, and now we can multiply 4 by 0.16 and get your answer all pretty. It ends up being 0.64 times the quantity 0.8 t to the 1/5 plus 2 all cubed divided by t to the 4/5. And whereas specifically for a prime of 32, so now we'll just take 32 and we'll plug it in here. I'll do that on my calculator. It's 1.86624. And this, of course, has a unit. It's hundreds of gallons per month. So maybe a little nicer to write 186.6 gallons per month. So a little shy of 3 years after this factory opens, pollutant is entering the water at a rate of about 137 gallons per month.